So the idea now, with the negative outside, you saw that before with parabolas. You take a basic parabola, the negative, made it open down. Okay? But now we're going to also have negatives inside and outside. Again, everything outside is going to be vertical, and everything inside horizontal. Outside affected the y. So we saw translating up and down affected the y. Inside affects the x. And so if we had, like we have at the top here, if I pick some random graph, we don't even know what this graph is. I then take that graph and put a negative out in front of it. It will take that graph and flip it over the x-axis. And it will take the y-coordinate and multiply it by a -1. If I took a random graph and I multiplied the inside by a negative, it would take the entire graph and flip it over the y-axis, a horizontal reflection. So now we're going to add reflections to the questions that we're doing. So here's our first graph, and it says sketch the image graph after reflection in the y-axis, state the domain and range. And the first thing I'm going to do is I'm going to underline this part here, and I am just going to translate that into all the different ways they can ask the same thing, okay? Sometimes the math isn't hard, but they ask the same thing with different words, and then it becomes hard. It's like, well, what does it mean this time? So if we are reflecting in the y-axis, can you see that points are moving left and right? So above this, you can write horizontal reflection. If they gave this in function notation, since this function is g, I'll use g, but sometimes people just write f for everything, that's fine too. This horizontal reflection, this means that that negative is inside. Okay? So they could just say, sketch the image graph after horizontal reflection. Sketch the image graph after a transformation of y equals g of -x. And sometimes they give the same thing by giving the equation of the line. Your y-axis, do you write that equation as x equals 0 or y equals 0? Your y-axis is x equals 0, right? If I draw here, I'll draw the y-axis with the green dotted line. That equation is x equals 0 because every single point on the y-axis has something in common. The thing that is in common is the x-coordinate is always 0. So even though it's the y-axis, the equation is x equals, which sort of, again, your brain would be like, I'd like it to be y equals because it's the y-axis. But no. The thing that is in common with every single point on the y-axis is your x-coordinate is equal to 0, and that is why the equation is x equals 0. So all four of those mean the same thing. We could say horizontal reflection. We could say reflection over the line x equals 0. We could give just the notation, function notation for this. And now we're going to draw our graph. So if I reflect over the y-axis, this one's 3 units away from the y-axis, so flipped over it'd be 3 units that way. This top point is 1, 2, 3, 4, 5 away, so I go 1, 2, 3, 4, 5 away in that direction. This one's 1 away from the y-axis, so flipped over it'll be there. This one's 3 away. There. Play connect the dots. And we've got our graph. Sketch the image graph, state the domain and range. Right now I have a confession to make. I taught period 6 class, and I did the last question with them. And you know how yesterday I said how important it was over and over again to reread the question? And the last question I did with you guys, I didn't reread it, and we forgot to do so. I'm so sorry. It's not a big deal. We just didn't label asymptotes. We can just forget about it. It's going to be okay. You're going to be fine. I just felt a little bit like a hypocrite because I told you over and over again you should reread the questions, and then I didn't on the last one. And it just happened to be one where I made a mistake then because I didn't reread it. Oh. Anyway, reread this one. We do have to do domain and range of each. So I need to do it for the red ones as well. And this time I'm only going to do one type of notation. So I'm going to choose the interval notation. Interval notation for domain, I'm looking at the smallest x value is -5. The biggest x value is +3. For the range, my smallest y value is -2. And my biggest y value is +2. On my original graph, the red one, my smallest x value was -3, and my biggest x value was +5. And in my range, my smallest y value is -2, and my biggest y value is +2. And I want you to notice something in the domain and range. I want you to notice first that the range did not change. Can you see that? Does that make sense? Because if we do a horizontal reflection, what does it do algebraically? It multiplies your x by a -1. Does it do anything to the y values? No. So if our original domain went from -2 to 2 and we did nothing to our y values, does it make sense that they'd still be from -2 to 2? But we did do something to our x values. We multiplied them by a -1. Can you see that in the domain answer? The original went from -3 to 5. But if I multiplied -3 by a -1, and I multiply 5 by a -1, it's now from -5 to 3. And this will be sort of some of the medium level problem solving questions that you might get. You might get a medium level question where I say, this is the original function's domain. I did a horizontal reflection. What's the new domain? And you don't have the picture. Because what did we do? We started with the picture, reflected the picture, then did the domain and range. But if we started with the domain and range, could you do the new domain and range? And you'll get questions that start you off in different places. So it's just something you have to think about. It's not extremely hard, but just making those connections as we go. All right, now I better read the question again. We are good. Questions to circle are 3 and 13.